Good evening all. Today we are going to discuss basic of wireless and its cellular concept. Cellular concept. AT&T proposed a core idea of cellular system in 1971. The cellular system service area subdivided into smaller geographic area is called cells. And cells are formed into clusters. Each cells served by their own lower power base station. Neighboring cells do not use same set of frequencies to prevent interference. In order to minimize interference between cells, the transmit power level of each base station is regulated to be just enough to provide the required signal strength at the cell boundary. So from the mobile station to the base station where the tower is being placed, that is having sufficient strength, to be transmitted from tower to the surroundings, its areas, coverage area of the base station. Core cellular principle is what? Small cells translate over coverage area. User handoff as they move from one cell to another. The cells in between the base station coverage area, if they are moving the same area of the base station which is covering by its transmitter, if it is moving up to boundary of the another base station, then it is known as inter handoff. And intra handoff if it is across the base station. The same frequency channels can be reassigned to different cells as long as those cells are spatially isolated, called frequency reuse concept, and this increases the cellular system capacity. So you can see here these are the cells which is hypothetically assumed that all the cells are formed in the hexagonal. This is conceptually assumed. So here you see that each base station or you can see here the things that here we are having the tower which is having going to the subscriber sitting in the car, it's moving from one cell to another cells. So in AMPS, which was 1G mobile technology, there it was directly connected to MTSO, that was office only. But whereas in 2G and 2.5G, it is MTSO has become MSC, that is controller, mobile service controller or center. In 2 and 2.5G, between base station and MSC, there is another unit, you can say there is base station controller. What exactly meaning of the base station controller? It is having the facilities of transport, is having the facilities, various equipment, place computers, data storage and other things in the base station controller. So this particular area. So what is happening is this particular cell that cannot move to, this is moving, the same frequency cannot be used here nest cell, but it can be used to nest cells. So the same frequency can be used far off. What is the minimum distance can be used to avoid the ISI interferences from the from other frequency which is defined to channels in the another base station area. That is called reuse frequency concept. Okay. Frequency planning. You can see it is required to determine a proper frequency reuse factor and a geographic reach pattern. Frequencies can be reused should be determined such that the interference between base stations is kept to an acceptable level. The frequency reuse factor f is defined as f less than 1, where f equal to 1 means that all the cells reuse all the frequency. Accordingly, we can see below the things is 1, 2, 3, 4. Okay, f equal to 1 by 3 implies that given frequency band is used by only 1 out of every 3 cells. Okay, it is reuse factor of 4. We are having, okay, this is use factor of 7. It means it is having, you can see here diagram, the dark area 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. The cluster, it is known as cluster, which is the boundary of the cells. Here it is cluster of 7, reuse factor of 7. Co-cell and clusters. Co-cells are cells in the cellular system which uses the same frequency channel set. The reuse of the same frequency channel should be intelligently planned in order to maximize the geographic distance between the co-channel base stations. Following figure shows the example of hexagonal cellular system model with the frequency reuse factor. F equal to 1 by 7, the group of cells which are using entire frequency channel set are called clusters. You can see that cluster 1, 2, 3, 4, 5, 6, 7. 7 cluster of 7, that is cells, and cluster boundary, dark boundary line is cluster. So see, you can see that the these cells are in the cluster is defined as A, B, C, D, E, F, G. Okay, right? So what is happening is the same frequency assigned to this cannot be used adjacent, okay, cluster, okay, cells, but it can be used reuse some the frequency which is okay allocated to that particular coverage area of the transmitter or the base station of here. So this is the different, okay, apart from the thing. This is called reuse factor. Cellular concept. The overall system capacity can increase by simply making the cells smaller and turning down the power. In this manner, cellular systems have a very desirable scaling property. As the cell size decreases, the transmit power of each bit also decreases correspondingly. That is the reason the most of the governments in the world, they have given to the, okay, notifications to the service providers that they cannot use the maximum size of the transmitter so that it should not affect to the its radiation should not affect to the animals and the human health, okay, drastically. So that is the reason that limit, you can, if it is height is more, definitely radiation will be more. So that is, if the cell size is less, the coverage size, it is also covering size, it will be less, and it will decrease the height of the base station, okay, tower. For example, if the radius of the cell is reduced by half when the propagation path loss exponent is 4, the transmit power level of the base station is reduced by 12 dB. Okay, so that is, it will be 10 log 4 square. 4 square become log 16, 10 log 16, that become 2b. You can understand how much it will change because this is exponent value. Handoff. Since I told handoff, the meaning is when person is moving, okay, talking and moving, and he doesn't know that he moved away from that original place that is connected to one particular base station. It is entering to the coverage area of the another base station. The power level of the, okay, base station that is getting means base station is providing the allocating the channel in terms of the frequency, okay, in FDMA. In terms of TDMA, it will be logical channels, where it is analog channels FDMA, FDD, frequency division duplex, okay, there. So that what is happening is moving, it has to send a request to the base station, or base station should see depending on which particular 1G, 2G, 3G. Earlier, okay, it was the base station, it was sending request that somebody is entering to my that areas, and it will be measuring the power. But later on, the 3G, the device itself is measuring the power. It was requesting to the base station requesting to the MSC, if it is moving the out of area of the MSC, if it the connected, it is moving to the nearby base station which connected with same MSC, then a request is sent by the computer, by the mobile subscriber, and that, so that it should allocate the new channels which is allocated by the, okay, new base station which is moving. So this is smoothly transfer, soft turn over, okay, one channel connected to one base station to another base station, a subscriber is not knowing. That is known as handoff. In AMPS, it was hard handoff, whereas 2 and 2.5G data and other things is used for the handoff technology, okay, logical channels and other things. Then it becomes soft handoff. But in it is also various other handoff type like inter or intra, concept of inter base station, intra base station, inter MSC, intra base MSC, when people are moving from one MSC, okay, long distance to some other, like a person is going from one our area Anekal to Malleshwaram, and on the way he is going on MSC, it is in, okay, uh, it is in one is in Anekal, while moving towards the Malleshwaram, okay, MSC, he will and many base station, okay, it will be there in the area, the coverage area. So MSC boundary, when you cross the one MSC, that is known as that handoff, okay. So intra handoff, it takes place where it is the same, okay, area, then it is inter. If it is across the different, okay, BSC or MSC, then it's called intra. So handoff is what? Since cellular systems support user mobility, seamless call transfer from one cell to another should be provided. For this, handoff process provides meaning of seamless transfer of a connection from one base station to another. Connection means providing another channel. Achieving smooth handoff is a challenging aspect of cellular system design, and that is many changes. It has evolved from 1G AMPS analog, okay, mobile technology to digital technology, okay, and there it will, okay, FDD, TDD, and CDMA technology. Later on, it has evolved. So this is changes a lot. So handoff, it is a technology where the person doesn't know while he moving in the car or walking or in whatever it is, whatever is speed, the technology is changing as per the G, 1G, 2G, and 2.5, and 3G, and 4G. Okay. So people are changing as soon as new challenges is coming, they are introducing new concept. That is the 1G is changing 2G, 2G to 3G, like this it is changing. Advantage of the cellular concept: small cells give large capacity advantage and reduce power consumption. Already we told how it is changed, and allows frequency use. Drawback of cellular system: in cell size decreases as the number of cells for the same area, service area, need more base station. Definitely more infrastructure, more tower. So that will be a question for the service provider. That is a question of how is a profit service provider has to make it. So of course, if it is more cost and more, okay, infrastructure to be installed, definitely they will be charging from the service provider people only. So it leads the frequent handoff, interference level increases also, and effect on service efficiency. Cellular capacity expansion tech. See, if we are sector, it is change. Means the sector is secting, we are making one small cells into many another, okay, micro cells or mini cells, that is known as secting. It is the capacity expansion technique to keep the cell radius unchanged and seek method of discrete DR ratio. Okay, and that we'll discuss later on how exactly this is DR ratio. Reuse D is reuse. Okay, reuse frequency use, and R is the radius of the cell. It is desirable technique to improve SIR, signal to interference ratio, without sacrificing so much bandwidth. Uses directional antennas by replacing the single omnidirectional antenna as base station. It provides interference reduction, hence SIR ratio increases. No capacity is lost from sectoring because each sector can reuse time and code slot. So each sector has the same nominal capacity as an entire cell. Cell capacity extension tech continuation, you see that the cell initially it is 3 by 9 frequency use plan. You can see that there are 3, 1, 2, 3, initially it is 3, and each part of sub cell it is changed to 3. So it becomes, okay, that become 1, 2, 3. Here you see 1, 2, 3, 4, 5, 6. That is 6 sector cells. This is 3 sector cells. Okay, so 3 sector cells is apart 120 degree, where 6 sector apart 6 degree cells pattern. Okay, this is the things we have to. This is increase number of channels are provided. Capacity is increase of the system is a, that is a reuse plan of the okay, you can use it. The same frequency which is defined after a particular D, which we have calculated for the sector level, it will be, we can use same frequency apart, so that the adjacent channel is not interfering to the other, okay, nearby channel. Cellular concept is each sector one point the same direction in each cell, then the interference caused by neighboring cell will be dramatically reduced. An alternative way to use the sector is to you reuse frequency in each sector, and the time code frequency slot can be reused in each sector, but there is no reduction in the experience interference. As the number of sectors per cell increases, the SIR also increases. Thus, the capacity of cellular system increases. Definitely, advantage of secting, it is effective tactile approach of OSI problem. It is antenna technique to increase the system capacity. Reuse number D. You can see here we are talking DR ratio. DR ratio D by R equal to 3n to the power 1 by 2. N it can be calculated by n equal to I square plus ij plus j square. So this will be depending how you can use a reuse frequency. You can see here, okay, one boundary of one sector, if it is moving in the sector which is 7 cells made one sector, okay, 7, if you use from F to A to C in one direction, and then anti-clockwise is moving only 1. So if the sector is moving 1, 2 up, and then it going to B. So if it is I only 2, 1 and 2 movement, and J equal to anti-clockwise 7, okay, counterclockwise movement, then you observe cluster given figure I only 2 and J equal to 1, then N becomes I square plus Ij plus J square 7. So this particular, if the radius R is 5 km, if the radius increases, D also increases. Okay, so 5 km, then cluster size N equal to 7. Okay, it means the cluster divided into 7 cells, and the distance is 22.913 km. If n equal to 4, Cluster 4, it is when we have shown earlier slides, n equal to 4, A, B, C, D, then D equal to 17.33 kilometer. So you can understand, mean the smaller cluster size result a smaller residue distance D factor. That's all. Thank you very much. I will go for next slides, next topic in the next slide. Thank you very much.